we had a conversation with a fairly local-based car rental company. And they were like, hey, we get loads of people coming to us asking about convertible cars. We rent them for a weekend. But the market seems really piecemeal. There's lots of demand, there's lots of spikes and troughs in demand. And we don't know if we should get into that bit of the market. Because buying convertible cars is very expensive. And we think they're just going to sit on a forecourt for a lot of years. Can you help us figure out if this is something we should get into? So their challenges were around what stock levels convertibles should they hold? How much supply do they need to have? Yeah? How do they allocate the supply of these cars to different branches they have around the region and around the country? Yeah? The one thing they say is that car rentals, to them, it seems like an impulse renting. Pretty much any other vehicle type, right? You rent somebody a van, there are trends to drive that. You rent somebody a car, there are trends to drive that. Usually people going on holiday or people traveling for work, right? But they just didn't understand what was triggering people buying rental cars or convertibles, renting them. So they had to sit down and try and figure out some of the data behind this. Well, not the data, but the decisions behind it. How about this? Somebody spent about £5,000 consulting on EY to get to this conclusion. The warmer the weather, the more convertible cars we rent. How's that for rocket science? That wasn't the end of the story, right? There are obviously other factors, right? Now here's the thing, in the UK we're starting to get to the point where we're getting temperatures where this is appealing. And not everybody goes out and rents a convertible car, there are other factors. Some of the other things, when we sat down and looked at their rental data, right, when we were getting these inquiries, right, people would want to rent a convertible sports car when the weather was warm, when the sky was blue, when there was no rain, and when it wasn't a work day. Quite simple, really, isn't it? You wouldn't rent a hire car just to do a daily commute, would you? So when it's like a long weekend, when it's a bank holiday, that's when people would want to rent a car. So what that meant was there was a little bit more features and labels behind this data here of how many cars they would rent based on the temperature. Yeah, and there's obviously like a bottom level, so if it gets beneath 12 degrees, nobody's renting a car. We also found, like, if we projected this figure a little bit further along, once it started getting above 40 degrees, we think the rental level will drop off again because it's too hot for people to go around in an open-top car. A very nuanced theory. So there are a lot of different factors in that. It's not just about the temperature. So how do you take a model as complex of, we'll rent a lot on a non-working day, or rent a lot when it's warm? How do you take all those different factors and create a model that you can predict how many cars you're likely to rent? The answer is machine learning. What we need to do is to get a data set. So fortunately for this rental company, what they were able to do was look at their inquiries. Because every time somebody asked them if they had a convertible car in stock, they were keeping hold of that data for the last couple of years. So in their CRM database, in their ERP database, we could go back and see a bunch of data. So for every date, they knew whether or not it was a working day or not. We knew the number of convertibles that had been asked for as well. We couldn't get all the data we needed from their ERP database, but we could plug into the Met Office's weather platform. They've got an API that you can query and ask it questions about weather. So we were able to figure out for particular days the maximum temperature and the maximum humidity. So this was our data set. This is what we pulled into this model. Now there are a lot of variables there, but what we were able to do was to extract from that this yellow line, regression. So what we do is we take these factors as a data set, bring them into Azure Machine Learning, have machine learning create a model based on the data that we've got. So rather than just writing a bit of software in Python or C# that says, if it's hot, do this, we let AI create the software model for us. We feed it the data, we let it come to the conclusions, we let it try several ways of working out the optimal model for that. Then we give it test data to see how accurate it is. What we get at the end of that is a service that we can feed into it. Next Thursday, we think it's going to be 36 degrees Celsius. It's a little bit optimistic for gas, I think. It's going to be clear skies, mostly from the weather office. We know it's not going to be a working day. How many convertible cars should we have in stock to meet demand? So, any questions about the data science part? No? Okay. What I'm going to show you now is how we can take that hypothesis and make it into a reality.
Do you need to be on the internet? Do you need to be on the internet, Doug? Are you?
Sorry?
Do you need to be on the internet?
I think I should be on already, actually.
Okay, cool. There's a Wi-Fi there if you need it.
Excellent. Let me just connect back to my phone. Probably the fastest way. So the first thing I need to do, if I want to do some machine learning, right, is I've got to create the hardware resources. And I've got to create kind of the runtime environment where that model is going to run. Now, fortunately for me, Microsoft Azure makes that really easy. If I come to the Azure Marketplace, which is where you go to choose the resources you want to deploy in the cloud, there is a whole section of about 3,000 different offerings relating to AI. Not all of these are being created by Microsoft. Some of them by third-party firms, some of them by Microsoft. So if I want to create a machine learning platform, I come in here and I search for machine learning, and I search. Now it's not just Microsoft offerings that appear in here. There's a whole bunch of third-party ones as well. But I want to make sure I pick this one here, the Azure Machine Learning Service. Now, I don't need to be a guru with Azure infrastructure to figure out how to deploy this. I just need to know some basic facts. So for example, a subscription, let me just zoom in on a bit for you guys. Who could tell me what a subscription is used for in Azure? It's the credit card, basically, or it's the billing account. This may come as a surprise, but Microsoft is not a philanthropic organization. Yeah, Satya Nadella needs yachts. Steve Ballmer needs to buy baseball teams. Yeah, Bill Gates needs to give away billions of pounds to make the world a better place. Therefore, we have to pay for what we use in Azure, mostly. So the subscription, yeah, when I choose the subscription here, I'm saying to Azure, this is where you send the bill to for this thing we're going to run in the cloud. We need to keep everything we build in Azure organized. So when I build something, I have to deploy it into something called a resource group. So I'm going to create a new resource group here called RGAI for E. And basically that's just going to be like a holding place. It's a unit in Azure where I can keep all the resources I build. So if I was building a data center, I'd need computers, hard disks, network cards. Same thing in the cloud. There's a whole bunch of components, and we keep them logically close together in a resource group. So we've got an existing one here called AI for Enterprise. I'll deploy it in there. When I deploy this service, it's a platform as a service offering. And by default, it's going to be exposed to the public internet. So when I do that, Azure is going to create a DNS name for it, like an instance name. So I need to give this resource a name that's unique. So I'm going to call this Dan Mac Lang, and hopefully, it should be an H, machine, short for Dan Machine Learning. And it gives me a green tick to say nobody else has picked that name before. So I'm good to go. I now get to choose whereabouts in the world I deploy this resource. There's a massive list. There's about 30 or 40 different regions now within Azure in some very exotic places. We've got 2 regions within the UK, UK South and UK West. So I'll pick UK West or UK South for this. My choice of region is normally driven by 2 things. Where are my users? I want my users to be physically close as possible, keep network latency down. But I also want to choose this location very carefully because whatever data I process in there or store in there is going to be subject to the laws of that geographical area. So there are 4 Microsoft regions in China. If I deploy something in there, Microsoft has to follow the laws of the land where it operates. So if I deploy data into a China region, Microsoft has to allow the Chinese government and the Chinese military free access to all my data. So data sovereignty is the other consideration here. So that's why I'm going to keep my stuff onshore in the UK. Now, there's a couple of other components that get built alongside my machine learning workspace. It's going to create a storage account, which is where it's going to keep the training data and the model data. It's going to create a key vault for me as well. Because when we start allowing users in to authenticate them, yeah, we need to have some sort of shared secret. Maybe I want to encrypt my data, so I need a place to keep the encryption key for that. So a key vault is basically high secure, highly encrypted storage in the cloud. Has anybody heard of an application insight before? Maybe tell me what an app insight is. Have you got a good definition?
Logs on steroids is the best.
Logs on steroids, yeah. Logs with kind of like an understanding of the code, right? So you can pull information out right out of the runtime environment and analyze what's happening and figure out where your code is faulting. And you can plug that into Visual Studio. So you're like, was it IntelliSense? IntelliSense. So I did this for Domino's Pizza a couple of years back. We created an app insight for an app that was failing. Inside of like 15 minutes of deploying the app insight, the logs were coming back and it was actually telling them, this module of code, this DLL file, your error's not in syntax, your error is that you're not initiating the hub you're trying to send a message to first. That's why your code's running slow. So it's kind of like AI about your code, almost. And then down here, if I'm going to deploy any of these services, so I'm going to build 2 things here. This first thing I'm building is the workplace, which is where I can build the model. Then I'm also building the resource that will be used to host the models we create. So what I can do here is create a container registry to keep that. So it uses a microservices architecture. So I'm going to call this AI for E, Dan, Mac, Learn, 22272, just to give it some numbers. And I can choose what level of charging I'm going to pay for that container infrastructure. There's a couple of other options I can take here. The default option is, say, this is a cloud service. So anybody on the public internet can connect to it. But remember, zero trust, right? Anyone can connect to it, but you can only access it and work with it if you can authenticate to it, right? Or if I wanted, I could lock it down so I could only get to it through a site-to-site VPN or an Azure virtual network. I've got 2 choices for encrypting the data I store here. The first one is to use a bunch of keys that Microsoft provides for me for encryption. Why might that be a good thing to do? Yeah. I trust Microsoft to deal with the encryption, right? The only problem with that is Microsoft will encrypt my data for me. They'll keep the encryption key in their vault, and they guarantee, right? They've made a public promise to the government, to the stock exchange, to the public, that they will never decrypt the customer's data without the customer's consent. Yeah? But if I don't trust Microsoft, or the regulator that looks after my industry doesn't trust that, I might have to use a customer managed key, which is where I create the key and I manage the key. But I kind of trust Microsoft. I can use this option here to give the service a managed identity within Azure. So if I want to connect my AI machine learning service to a database or a storage account, I can use that credential to do that. And then finally, obligatory within the cloud, I can put some tags. So what I'm going to say is I'm going to put a tag on here. It says the environment is production. If you're not familiar with tags, they're basically the sticky notes of the cloud world. I'm not building something physical, so I can't put a label on it, but I can attach tags to describe the thing I've built and its properties. Now I click create, and it's going to go away and build that resource for me. Anybody want to guess how long this is going to take? Minutes, seconds, hours, days?
I know it takes me about 5 minutes to create an IoT hub sometimes.
Yeah. IoT Hub's interesting because there's like firewalls built into that and network connections. It's deploying a collection of resources for me here. It should take about 2 minutes, if that. But still a lot faster than picking up the phone and saying, "Hi, is that HP? Yeah, I want 6 servers, please, and a SAN, and a fiber optic network. Yeah, I've got to check for £250,000 from my from the CIO, from the CEO." There we go, it's built. Now if I click this button here, I'm still inside the Azure portal. So what I'm seeing here is the infrastructure view about my resource. So the resource in this case is called a machine learning workspace. So this is the infrastructure that we'll deploy machine learning projects that we call models onto. So over here I can come down, I can look at the networking config. If I wanted to switch it across to being private, I can do that in there. The most important thing I can see in here though are the logs, which will start populating in about 5 minutes time. And also, where are we at? If I come up to the overview page, oh sorry, access control and identity management, here I can grant other developers access to this workspace so they can come in here and build solutions. What I want to do though is to open up Machine Learning Studio. The portal is all about looking after my infrastructure. If I want to build a solution, I come into the Machine Learning Studio. So what we've got is this nice, neat user interface. This solves 3 challenges for me. One is it's this brilliant repository of templates for different models. So there's a whole bunch of pre-built models, pre-trained models as well I can take and start working with. There's also the ability to take and create a model from here and deploy it onto my infrastructure. So if I click this button here to create a workspace, I could use this wizard so my software developers can build a machine learning workspace like I've just done in the Azure portal. They could do that without having to leave the developer tool. So that's quite useful. But I already have one of these in place. If I connect to my workspace, I can see here a list of all the different project types I can build. There are kind of 3 main ones, 3 main machine learning projects I can build. One is called a notebook. So if I'm feeling codey, yeah, I can get some Python or some R and just copy and paste that code into there, and it'll run like a function in there. Or I can do automatic. machine learning, or ML ops, where I can basically give it the data and have the machine learning service work out how the model should work for me. So what I'm going to do here is come over to automated machine learning, and I'm going to create a new automated machine learning job. So I'm going to call this car rentals prediction. And what I'm going to do is going to train a model that knows how many cars might be rented on a given day. So I'm going to create a new experiment. So I'm going to call my experiment car rental prediction underscore EXP. So I know that it's an experiment. This model looks at weather and working date info to predict the number of convertibles we now I can choose from a particular type of machine learning model. Now, maybe familiar with data science will tell you we've got classification model. So classification is where I know I've got a bunch of records. Some of them fall into this classification, some into that one, some into that. I can create a model that can look at my data and figure out which of those existing classifications it goes into. Or I could create a model based on computer vision. So I could train a model with like a whole bunch of pictures and labels that say what's in there. So I could give it a picture of, so I give it 500 pictures of fruits like banana, apple, and we could play what's my fruit. What I'm going to use though is the regression model. And what I need to do now is to create a data set. So I'm just going to put a description of historical car rental data in here. I need to tell it what kind of table it is. Yeah, we've got two. We've got table or tabular. Yeah, table is where it's stored in something like a NoSQL or a semi-structured database. Tabular means it's just like in a CSV file or an Excel file. So the data I've got's in a CSV file. Now I've got a bunch of choices here where I go to get this data from, right? The first choice is to go to an Azure storage account. That'll be neat because the data will be close to where the workspace is. But I could also point it to like locations like websites. But what I'm going to do is just upload a CSV file that I've got. And it should start prompting me. Actually, I'll tell you what I'll do. I'll point it at the web location. Let's just get the URL for this. I need to be careful with this window here because I've just put a URL in there and I kind of instinctively hit enter or had a carriage return and it makes it say that the URL is invalid. All you do is just take out that carriage return at the end. So tempting just to hit enter, but on this, watch out for that on this screen because all you need to do is just hit the next button once the URL is incorrect. What's happening now is it's connecting to, I'll just quickly show you what this data looks like. It's just a CSV file hosted in GitHub at the moment. So you see we've got date information, whether it's a holiday or a working day, and temperature information in CSV format. So it's pulled in that data, and it's detected some patterns in that data. So what type is it in? It's delimited because it's in a CSV file. It's figured out that there's commas separating the data. So if it has any problems picking up the data preview, I can modify that description to match the data that I've got. But I'm happy with that, so I'm going to say next. And so it's come back, it's detected the data types in there. Mostly it's integer files, which I'm happy with. And then I'm going to create that data set. So all that's done is just grab that data, brought it into that storage account that I created as part of the workbench. Now what I can do is create a training job based on that data. So what I need to tell about is the targets column. The target is, so remember, we're telling this with that data how to analyze the data. So we've told it what the questions are and what the answer is. So I guess the questions are like, if it's this hot, if it's this day of the week, and the answer is how many cars we're going to rent. So I'm just going to come down here and pick this row here, rentals. That's the information we want to get out of this. When we train this model, we're going to give it weather information and day of the week information and time of the year information and pull out of it how many cars we expect to rent. Now, just creating a model by itself is okay, but what I want to do is create a model and have this platform go away, iteratively create a whole bunch of different models and figure out which one gives me a prediction most accurately. So what I'm going to do is tell it to split my data. And I'm going to tell it to hold back 10% of the data that I've put in. So we'll use 90% of my data to train the model. The last 10% it'll use to validate the model, just to make sure it's good. And by doing that, it means it knows how accurate it is. Because it can do that, because we've told it if the values are this, the outcome is that. So let's use that. Now this being the cloud, this is a great place to run these models because they require a lot of horsepower, right? Does anybody want to guess how much the most expensive virtual machine size is in Azure? Do you want to see something real scary? I mean, I can deploy some pretty powerful stuff here in Azure. If I come down here and look at the virtual machine sizes, what's this? See all sizes. This is usually I show to people when I want to try to scare them into buying a governance or a FinOps engagement. I'm going to remove the grouping, zoom out a little bit. So these are all the different virtual machine sizes in Azure. That's the cost is over here on the right-hand side. So I mean, I could go pretty cheap, right? I could buy something from about £3.50 per month. Any guess, rough order of magnitude, what the most expensive ones are?
£1 million a month.
We're up to 1,000, 2,000, 3,000, 4,000, 20,000. Look at that. £73,000 per month. What do I get for that though? I get 64 data disks, I get 416 CPUs, and I get 11 terabytes of RAM. So the question there, right, is if I'm training models, I need really intense compute power for a short period of time. So if I can have access to all those CPUs, it might train the model in 15 minutes. If I've got a massive set of data, I might need something that powerful. But remember in Azure, we're not paying for what we deploy, we're deploying for what we consume. So if I come over here and I launch the calculator app, and I say, what do we say, £74,000. Yeah. Divide that by 730 hours per month, ballpark. If it only takes me 15 minutes to train the model, it's only going to cost me £25. Or if it takes me an hour to train the model, that huge amount of infrastructure, I can have it for £100. So one of the beautiful things about these training jobs is I can tell it to deploy a really powerful compute instance, or have it create a high performance compute cluster, run it, do what it needs for it, get the data out of it, and shut it down and stop paying for it. And because this is kind of a machine learning job, this model starts the virtual machine and shuts it down. So yes, I might spend a bit of money, but the cost is, I might use a lot of horsepower, but the cost is kept down to a minimum. So over here, I'm going to just choose some cheapo virtual machines. I'm brave enough to show you something that costs 75 grand a month, but there's no way I'm going to deploy a virtual machine that costs more than a brand new Jaguar XJ per month. So I'm going to choose, let's have a look. Here we go, a memory optimized DS11 machine. Actually, 2 cores? Nah, I can be a little bit more generous than that. Let's have a look. See over here, this is what we pay per hour for these virtual machines. So let's go with 8 cores and 16 gigs of RAM. 4 cores, oh, here we go. 4 cores and 32 gigs of RAM. Let's deploy it to that. It's not going to let me. Actually, let's take one of the recommended sizes. One of the things I can also do as well is I can choose whether I'm going to deploy it to a virtual machine with a CPU, or whether I deploy it to one that's got a GPU in it for extra power. So this compute policy needs a name, so Dan Mac Learn VM. Why not? So here's a little bit of information. Can I enable idle shutdown? So what I'm going to do is I'm going to shut this machine down after it's been idle for 15 minutes. So I want power, but I don't want to pay for it when I'm not using it. And if I wanted, I could create a schedule to say when it's on and it's off. I can stay in charge of these prices, these costs. So it's creating the virtual machine. In about a minute's time, it'll create the VM, and it'll allow me to deploy my experiment to that virtual machine. And that experiment will take that data and analyze it several different ways using different algorithms. And it'll figure out the most relevant algorithm that gives me the most accurate result. So I'll give that a little bit of time to run through, and what I'll do is I'll cover off some of my other slides whilst that's happening. Any questions?
You clean the data set. Can you clean the data set on Azure platform?
Sorry, I didn't hear you very well.
Can you clean the data set on the Azure platform? Or you take in the...
Yeah, I mean, your data set can be anywhere, really. It can be like a database, as long as you've got some sort of URI to connect to it. It could be a storage account in Azure. It could be a storage account in Amazon, as long as you've got keys.
Yeah, but we need to cleaning our data set, yeah?
Yes, your data's got to be good. If you give it rubbish data, it'll get rubbish platforms, all right? So I'll tell you an example. I did some work for Shell a couple of years back where we trained an oil field prediction model. And the whole idea is it would look at the temperature of the water at the surface, sorry, the seafloor, and it would try and predict if there's an oil well under there. And our data was all over the place. And what we found was some of the thermometers were in degrees Kelvin, some in Celsius, some in Fahrenheit. So we did data engineering and just converted them to the right formats. And all of a sudden, we're pinpointing wellhead locations pretty quickly. Excellent point, yeah, your data's got to be good. So let me show you what this is going to build. This is kind of the architecture of what we're going to build. Now, the service we're going to create is basically a software engine. It's going to be connected to the public internet, and it's going to listen for applications asking it if the weather is like this, yeah? So what is our label data? How hot will it be? Yeah, what's the maximum temperature predicted to be? Is it a working day? All that data, if we give it those parameters, it's going to go away, right? It's going to take that HTTP request, pass it into the Azure Learning resource, which is basically that managed virtual machine, and it's going to run that model. So it gets the HTTP request, and it returns back to me a JSON output. Maybe tell me what JSON stands for? Is that like a really dumb question from the room?
JavaScript object.
Excellent, good. Always like to check a level. It'll give me a transaction ID, but it'll give me my feature data back, which is basically, if it's the 3rd of July, if everybody's on holiday, and the weather's really nice, we're going to rent 450 higher. Now, the software side of that, the logic side of that's pretty sound. That kind of model you can apply to almost any organization. Even if you take a city center nightclub, right? Nightclub owners are forever trying to figure out, well, how busy is town going to be? How many doormen do I need? How many bar staff do I need? How many spare kegs of Guinness do I have? And guess what? That extra cost might be as much as £300 or £400 per night of expenditure. And all they could tell you is, well, last Friday it was busy. This time last year it was heathen. Oh, it's St. Patrick's Day. It's really busy. This type of approach, this kind of model, you can take and apply to almost any business. And all of a sudden you've got this bit of software that will answer the question. So down here is our consuming app. All it's got to do is write some HTTP, send some JSON, get the results back, and deal with it as a variable. Now, Microsoft have created SDKs for Python, C#, Java, JavaScript. The Java won't work just fine in Java. So there's even a bunch of commands that you can, just like a unit for Python, you can embed into your code and it intuitively knows how to work. Does that sound like it's going to be feasibly built? Cool. Excellent.
Can I just ask, obviously you've fed that a static data set, but if you wanted to feed in a dynamic data set that's changing over time and retrain that model on like an interval,
Yeah.
That's why it's schedule.
Yeah.
The schedule, so you schedule every month as the data grows, it will get more accurate.
Yeah, absolutely. So there's an automated ML script in there. And I can do one of two things. One is I can create a pipeline, which is basically just like, it's like a logic app, or you've seen logic apps in Visual Studio? Just like that, graphically create a sequence of workflows of what I want the machine learning job to do. Get a trigger when the database is being updated. Pull all the data into the data set again, pull it in, train the model, compare the data. If this model is better, it's more accurate than the last one, replace the model with it.
is there any risk, I guess, that you put in trust in the models behind the scenes, and like with great power comes great responsibility, right? Like we don't understand, as developers, we might not understand the intricacies and how it's actually getting to these answers, and we're putting a blind trust in this, you know?
Yeah, absolutely. I don't trust anybody or anything, which is why I look at the data. One of the values we'll get back out of this, right, is something called a confidence rating, which is usually based around how, what we call the precision of the model, which is over time how accurate it is. But this is why you don't just build the stuff and walk away from it. You keep looking at it. And remember, we've got this whole thing of responsible AI use. So transparency and oversight is key to this stuff. I had a conversation with a CEO about 3 weeks ago, and he's saying to me, I don't understand why you're telling me my organization's culture has to change because we use AI. We literally just bought CoPilot, right? And I said to him, do you treat your managers differently to how you treat your individual contributors? I call them people that work for them. Because of course we do. We pay them a lot more money for a start. Why? Because they're responsible. Okay. Do they do any work? No, they give people work to do, but they're accountable for their output. Exactly. So you have hire managers that can tell people how to do the job, that can coach them and train them to do the job, look at the output and adjust their performance? Yeah, absolutely. That's why you need to train your workforce, because your individual contributors become line managers. They are managing, they're responsible and accountable for the AI tools they're going to use and operate to get the job done for you. That's why you need a slightly different culture for this stuff. And, you know, writing a bit of software once and walking away from it, we all know that doesn't cut the mustard, does it? So you've got to keep coming back. Supervision, right? Creating an AI model is like having children. Guess what happens if one of my kids goes out and gets into a street fight and he's under 16? Yeah? The kid gets told off by the police, but who's legally accountable? Who can get sent to prison for it if he's not done his job as a parent? Yeah? Great power, great responsibility. That's how it works. Good. Any other questions? Okay. Let me just talk about something. So you've probably heard of Microsoft CoPilot, right? Has anybody been hiding under a cave and not heard of it? So Microsoft CoPilot. Microsoft is a major shareholder in OpenAI. Who can tell me the kind of 4 offerings OpenAI have?
ChatGPT,
Yeah.
Sora, DALLE.
Then
DALLE, yeah, embeddings, yeah. So what Microsoft has done is they've said, this model's great, but why would our customers want to send their data to OpenAI's cloud, have the numbers crunched there, then the results sent back? They want to keep a hold of their data in the same place. So what you can do in Azure is you can deploy OpenAI services in your Azure subscription, have it processed by DALLE, ChatGPT, embeddings locally within the environment. What they kind of built on top of that was this idea of, well, what if we just build conversational AI into some of our apps? So at a basic level, we have this thing called Bing CoPilot. So it's a website you can go to, copilot.microsoft.com. As long as you've got a Microsoft Live ID, you can sign in, and you can do generative AI with it. I'll show you that in a second. This is something that's very close to release. It's in public preview at the moment. This is GitHub for Copilot. Sorry, Copilot for GitHub. The idea here is, if you think about the stuff we do in continuous integration, continuous deployment, there's a lot of heuristic stuff in there, but there's a lot of common good practice, like security checks, vulnerability checks, debugging, performance testing. Copilot for GitHub can help you build and improve your CI and CD pipelines. They can look at the code you're building and estimate how much CPU resource you're going to use. It can look at the application insight and tell you your infrastructure needs to be more powerful. It can up the sizes of the templates for you. It can run the security checks. It can even help you write code. So that's Microsoft embedding Copilot into GitHub. It's also getting embedded into the Azure portal as well. Create a Kubernetes cluster for me, please, Copilot. Bang. Go away to it. It's getting built into the web browser. Guess what? Conversational AI is really not that different from web searching. Does anybody know where the word Bing comes from? We all know what it's synonymous with, isn't it? Second-class web search. It's not as good as Google, right? Tell everybody that kind of this, right? Bing is called Bing because it is short for the Bill Gates thing. It was the last bit of software Bill Gates personally architected. Now, if you look at what Bing does as a search engine, it's okay. When Google gets more hits, it gets way more data. It's a much better search engine. But what Bill Gates built as a search engine is a lot closer to a cognitive search engine, a large language model. Yeah? That's why they've kept the Bing branding to tie it back to some of the pioneering work Bill Gates did. Oh, I've got time, yeah. I'll quickly do a demo of some of the Copilot stuff. So this is Copilot on the public web. There are two experiences to this. The first one you get, right, is based on your account. This is my Microsoft 365 account. When I sign in with my work account, yeah, I can ask it anything and it'll go away and figure it out. But this is the architecture that it's built on. So this is the architecture of Bing CoPilot, right? It's got the 4 OpenAI engines in there. You authenticate with your live ID, and you've got access to all the data that's on the public internet, which is okay. That's what happens if you sign in with a Hotmail account or an Xbox Live account. If you sign in with a Microsoft 365 account, this is what you get. The same 4 OpenAI models, but connected to your Teams. So I can ask it a question from the Teams user interface or from Outlook. Did I commit to any action points last week? And it will go away and look through the transcriptions of all the Teams calls I was on last week. So yeah, on Thursday you committed to Jenny that you were going to create a wireframe for that project. On Tuesday you committed to reviewing the status reports and you said you'd get back to Abigail by Thursday at 5. If I'm invited to a meeting and I didn't attend it, oh yeah, James from accounting gave you an action point to resubmit your expense claim. And you can ask that through, so these embeddings, the user interfaces are built into the Microsoft apps now. Yeah? So not only do you get access to the data that's on the public internet, but you can get access to the data that's in your enterprise. First question that comes up of every InfoSec security person's mind is, what about privacy? I'm accessing all that data using my Azure Active Directory identity as an end user. It has access to what I have access to. So if you're going to build this for a customer, get the role-based access controls right first. Yeah. I can also connect it to databases and storage accounts and bring that data in here. SharePoint, I've got all my product documentation on there. I've got all my design documents on there. I could go into Word and say, help me write a low-level design document for a Microsoft Teams solution. Help me write a low-level design document for an Intune solution. And it'll find the templates, it'll find the work I've done in my SharePoint sites, bring it back and help me build that out. Ooh, I haven't listed CoPilot for PowerPoint on here. I never do that, because that's how I built this slide deck. I just went into PowerPoint, yeah, brought up the prompt, so what's this? Create a slide deck for slide deck for infrastructure as code with Terraform. And it'll go away, it'll research the internet, it'll research SharePoint where I've got documents there, come back with the contents and a structure and build the slide deck for me. It would probably help if I could spell. I've never been good with Surface Pro keyboards. So what's beautiful about CoPilot for Microsoft 365 is our data, the data of our organization. Where's my next slide go? Oh, there you go. There's that slide it's built in there for Terraform infrastructure as code. I was wondering where all these extra slides had come from. This just dropped it right into my deck. Lovely. So what I'll quickly do is just show you this, and then I'll close out. This is the architecture of Azure Open AI. If I'm using OpenAI normally, if I just use it for a web page, or if I try connecting my data to it, normally these models run in OpenAI's data center. So I've got to trust their cloud to process my data. I've got to ship my data there. And the numbers get crunched there and the results come back to me. Not a lot of companies are happy with that. Well, SMBs are perfectly happy with that. Large, medium enterprises, regulated customers, not so happy. So what I've got here is the ability to deploy an Azure Open AI resource in Azure. And I can choose to train any of the OpenAI models and host them in there, inside my cloud, inside my sphere of control. So all that power, and of course there are SDKs for everything. Yeah, I can use the CoPilot plugins to access this stuff, but I can also use the SDKs to embed the prompting and the returns into C# apps, Python apps, websites, you name it. But what's special about this is the data is being kept in my cloud. I can connect it to my Office data through the Graph API. I can connect it to my enterprise apps like Salesforce, SAP, Dynamics, or Facebook. I can connect it to my cloud apps like Salesforce.com, Concur, Facebook, Instagram by using the Entra ID enterprise apps. And I can also plug it into my file shares, my storage accounts, my databases. OpenAI in my data center. So what I'm going to do now, there's a whole bunch of extra stuff in here that I'll let you guys, I will give you guys a copy of the slides. So a lot of this stuff is a little bit more, you've heard about speech recognition and speech synthesis before. Guess what? People are using that in contact centers. That's what those last 6 slides said. To close out, this is what I want to talk about. These are the barriers to OpenAI. You saw how relatively easy it was to build that. Yeah? So the cloud gives us the infrastructure, Microsoft gives us the tools, OpenAI gives us the engines. What's missing, right? Lack of vision. You go and speak to a nightclub owner in your castle and say, how about AI? What are they going to say? The hell do we need AI for in a nightclub? Talk to them about predicting how many doormen you need, how many bar staff, how many spare kegs of Guinness do you need this weekend? Yeah? You can build something like this and it'll cost £20 or £30 a month and save them maybe £1,000 a month in staffing. And you can give it to them on a mobile app because it's front end for it. The skills gap. Yeah? We need people that can do this. Right? It's easy enough to build this, but unless you've done it a couple of times, it's kind of difficult. The hardest bit, though, within a client organization is the culture for AI success. I piss off a lot of CEOs. I say to them, they say to me, well, how does my culture need to change to embrace AI? And I say to them, you're going to be happy, have to be happy to see your staff pack their bags and go home at 2:30 in the afternoon. And they take a double take, step back like that, and do a double take. And then they look at the AI, the EY badge, and think, why is somebody from a glorified firm of accountants telling me my staff can go home at 2:30? That's not productivity. You need to look at the work output. Look at their productivity, not their presence. Yeah? If you're giving them AI tools, they're going to get the jobs done faster and more reliable. And if you just keep filling in the blanks with more time, they're not going to bother to, because they're the ones coming up with these models. They're the ones implementing this stuff, especially with CoPilot. If you don't incentivize them to get more done in less time, if you just fill them up with more work or more responsibility, they're just going to go back to doing things manually. There's no encouragement for them. So all of these kind of concerns, you can address through consultancy and leadership. Making sure people know, understand what this can, will do to their organization. Yeah? Buying them into the vision. Leadership. It's not just about the people in technology. Yeah? The chief executive officer, the managing director, has got to be happy, he's got to be ecstatic to see his staff going home at 3 o'clock in the afternoon. You've got everything done, you did? Yeah. How are your sales stats? Great. I'm 110% of my target. What does that mean for employee retention? Your best employees are not going to leave because they've got a work-life balance. So making sure that organizations understand this. Does anybody really think in 5 years' time people are going to be working a 40-hour week anymore if they've adopted this? You guys know, what's his name, American politician? Bernie Sanders, you heard of him? He's just literally put a bill through Congress saying that America should adopt the standard 32-hour working week. Because that's the only way to preserve people's mental health and work-life balances. Here's how it can be done. This is what customers struggle with, the ability to execute change. It's one thing creating software, but it's another thing getting permission to connect to that data. It's another thing getting somebody to open up the checkbook to make this stuff happen. Remember what you said before about power and responsibility. If I build a tool, if I operate a tool, if I make a decision based on what that tool has told me to do, I'm responsible for it, right? So people are struggling with the whole idea of what are the legal and ethical worries. And again, privacy and security. We get organizations to build this thing called a center of excellence, which is a team of people from within their organization that know how this should work, how to work with it. They create a set of governance rules. How is governance different from policy? Policy says you must do this, then you must do this, then you do that, and you can't do this, you can't do this, you can't do that. Right? Governance is about saying, right, there's a whole bunch of tools out here, take them and use them. But we're going to put guardrails in place to stop you doing stupid things with those tools. So like, if there's credit card information in the data, you can't send that outside the organization. You create a safe environment with governance to stop people screwing up, and you keep feeding that. And then finally, the last two big issues are really like access to the data and the sheer amount of compute power necessary for this. Cloud computing just helps with that. It just makes it easier. APIs, services, okay, a great big massive monstrous virtual machine, but you only need it for 15 minutes. A lot of options out there. Okay. Any questions? I think I've covered off that.
You mentioned that CoPilot is being built into the Office 365 suite. Is that just part of the standard license now?
We don't think of Microsoft as being a philanthropic organization who they want to get paid for it, right? So if you want, so CoPilot Bing, which is the stuff you get through Open, it's free. Just create a live ID and it's yours to use. You want to connect it to Microsoft 365, you have to buy a license for it. It's about £300 per user per year. So again, it's difficult to go out and sell this unless you're talking about productivity. You know? And most organizations, they see productivity as people are at the desk from 9 to 5. If you give them a tool that means people can be finished at 3 o'clock in the afternoon, how does that make their goal go faster? So it's all about understanding productivity.
These models that you're training, how do you rate them? Like, let's suppose there's a model being run for over a few years, then there's a model that's only not being generated. How could you be, be rated in order to say, these data or information is legit, I can trust it? It's very difficult.
That is really difficult to do, right? Because it requires like a mix of knowledge, right? You need people that understand how the business works. Like, so for example, I knew a guy that was smart enough to say we rent more convertible cars when the sun shines. And you need to drill into that to get all the nuances of that model, right? Then you need people that can go away and find the data. And then you choose the right kind of template and the right type of models to train it around. But a lot of that work ML Studio is doing for us. But what we need is a kind of basic understanding of what are the different capabilities. Something like Machine Learning Studio or OpenAI Studio uses. What are the templates that are there? But what you'll wind up doing is figuring out, okay, well, this is the theory, this is the scientific theory about the data I want. What type of model I want to use. It's a really great place to go to learn about that. Microsoft has a course called AI 900, the Azure AI Fundamentals course, that talks through each of these models. Yeah, and it'll tell you what each one does. You'll get a great appreciation of the different types of Azure resource you can build for this stuff, And the way to understand this as an AI person is to understand the JSON you send in and the JSON you expect out. Then it's very easy to kind of align that model, that template, or the model style to a particular challenge. It gets easier the more you do it. So this is the great thing about IT. When I started doing this 25 years ago, it was about unpacking boxes of computers. You know the BT call center? Up in Momentum, my first job was installing workstations and servers up there, and networking them together. It's not about unpacking hardware anymore, is it? It's about listening to what the business wants and needs and giving them that. Low code, no code, AI. The development side of this is going to get easier, but what we absolutely need is people who can talk with users, understand users, structure a conversation, and align a solution to it.
Where do we start as developers then? I guess if you work in an organisation that is maybe historically risk averse,
Yeah.
as a developer, how can we initiate that conversation and get it started to open up the doors for this?
Do you know what? So as a developer, right? I always say with this stuff, start with what you know, right? So the best place to really sort of show the value of this stuff and gain some trust in it as a developer might be to show the CoPilot for GitHub. Yeah. Now at the moment, it's a little bit difficult to get free trials of this stuff, right? But I've just literally pestered my boss. Yeah, so look, I need £300 to buy a license for this. And now I'm running around showing people, right, here's CoPilot for GitHub, here's us improving our CI/CD pipelines. Oh look, we've got some credentials in a Terraform script, not in a key vault. Yeah? And you get people used to the idea of trusting AI for that. They see the kind of complex scenarios they can deal with. The mistake a lot of companies make, especially the Big Four, is we've gone out and asked the Chief Executive Officer, the Chief Operating Officer, where is your business inefficient? Do you tell your boss about the stuff that takes you 20 hours a week to do? You might moan about it, but you don't go out of the way to talk about the areas where you're inefficient. So you go and you spend time in the coalface. You look at the people in the contact center. You look at the people in reception, trying to book meeting rooms. You look at the people actually doing the day-to-day job. You find out one or two things that really suck for them, where they waste a lot of time. We want to make that as a proof of concept. Machine learning, I can have that up and running in Azure. It can cost me no more than £20 a month. And I can create a simple app and host that for about $25 a month. I can get building with this stuff. If you come across something you think is a great idea, software as a service of it. You know? Great question. Any others?
Does Azure supports deep learning as well?
Sorry?
Does Azure supports deep learning? Or
Yes.
just-
Yeah, deep learning, machine learning, automated learning, large language models, pretty much everything. It's tempting to think of Azure as just Microsoft stuff. But if you look in that marketplace, there's now about 2,000 different third-party AI offerings in there as well. Even Red Hat, even HashiCorp, Terraform, they've got AI models going into there now as well. So was there another question?
Yeah, it's when you look at the left field, so tell us the question on the spot. It's largely around testing outputs from the AI solution. I've recently done a project where we built in some AI-powered features which was really cool. A problem we ran into though was testing the output where we use an LLMs to generate content for a third sector client and they would then send over their customers. We hit a bit of a snag because with a verified string coming out, in terms of what that string says, we've got a clue.
Yeah.
The only thing that looked vaguely possible, other than having a human in the loop, was having some kind of supervisory AI to sit on top of that. But then we get the problem of who's watching the watcher at that point. Do you have any ideas or strategies on effectively testing the outputs of these? Or anything that could solve a problem for me, basically?
Yeah. You actually hit upon the answer there. The human being in the loop. You're going to start seeing jobs being advertised for the role of AI wrangler. That's not necessarily a software developer, that's somebody who looks, understands a business process, understands a problem set, and looks and supervises the results coming out. A friend of mine is actually doing this job in a bank where they do mortgage applications. And he had to flag up that he thought there was bias built into a mortgage approval application. Because every time a woman with children applied for a mortgage, she was being excluded, regardless of credit score. Turns out their model looked at the consistency of payments going to the bank accounts. So of course, when somebody goes on to maternity leave, they take statutory maternity leave, uses big law. So even with language models as well, you've got to have somebody looking at it, especially in the early days of adoption. But what they can do is they can start embodying their knowledge into a supervisory AI that flags up. And what you've got to be doing is looking at the confidence ratings that come out of these predictions. You're coming back and saying, okay, that's a dodgy response. So let's handle that as an exception. Let's intervene. Let's look at that, send that to a human being, and then respond back from there. So yeah, you can't take human beings completely out of the loop. You've got to put the right human being in. And it's like being a parent. It's like being a manager. Yeah. Any more questions?
Once a model is trained, are you still limited to running it on Azure?
Curiously enough, no. Anything I run on Azure these days, right? If I can run it on a container, I can now run it on any Kubernetes cluster I like. In AWS, on-prem, and use Red Hat OpenShift even. But I do have to pay Microsoft some money for that. Yeah, because what you pay for in Azure, 50% for the software, 50% for the hardware. So if I take one of these models and deploy, say, the Vision service or the Open AI service on a Docker cluster at home, it'll talk back to Azure and tell us how much it's spending on the software, on the transactions. You can pretty much anywhere you can put Kubernetes, you can run.
What do you think about the future of AI software engineer like Devin.ai? So what
Development AI.
Yeah. So Devin.ai, like AI software engineer.
Yeah. We faced the same existential crisis in infrastructure 10 years ago. Hang on. 70% of what I did was building domain controllers and exchange servers. And now there's this Microsoft 365 thing. So we had to kind of adapt to becoming more aspects of policy, adoption, governance, right? As a software developer, I think you're probably going to see maybe 10% of the software industry develops and trains AI models. And they're going to be very, very highly paid, very respected, right? But then you're going to have another part of the industry which job is to get AI working. Now, it doesn't necessarily involve coding. That means being able to communicate with the users, to gather the requirements, to structure a conversation, to get the requirements nailed down. So I'm going to see a lot of people moving towards maybe being more of a business analyst who produces a flow chart of how this stuff should work. But those flow charts are not just going to be like a Visio document. Those flow charts will become logic apps in Azure that will create a pipeline, or they'll become the basis of the ML model that starts to be trained. So we're starting to see, right, so who still writes software in C#? So a few people. How many people are writing in Python? Okay, what was that split 10 years ago? Everybody was C# or Java. Right? Now Python is much more in demand. It's a higher level language. We're going to see low code, no code take off even more. That doesn't mean to say you can get away without knowing how to code, without knowing how data works, without knowing how security works. Yeah? Just be prepared for the tools to do more of the job for you. But how do you differentiate yourself? It's by getting things done. Who here works as an in-house IT person, like for an IT employee? Like who works like in the IT department of the company? One or two people, right? What's the one thing IT departments struggle with doing? Making changes because you're worried about a queue of people coming up to the IT office saying it's broken. Yeah? And getting things done because you're worried about clicking the button. This is what's needed in the marketplace. People that can communicate with end users, get people on board, get them enabled. Yeah? So we're going to need more people in software. We're going to need more people that understand software. Yeah? But would I want to be a graphic designer with DALLE out there? Maybe not. Do I want to be a web page developer? Probably not. Want to see something really cool? You've probably seen this before, but I always like to do this to scare people. This is the free user interface for CoPilot. Write a Space Invaders style video game in Python. There's the code, there's the spaceships, there's the bullets, there's the energy levels, there's the shields. There's the logic of moving the spaceship around the screen. It's just Python. Anyone can write Python. I'm a C# developer. My job's safe as it is. There you go. There's the video game in C#.
Did do
So this is the thing, right? Is it writing the entire project? No, it's not, but it's giving you the basics of it. It's giving you the foundations. You still need creative input. What we need is people to figure out what software should be doing and how it should be doing it and getting people to use it, you know? Cool. Any other questions?
Brilliant. Thank you, Dan.
No problem.